Okay, in this video we're going to be doing Calc AB Problem Set 127. The problems and a playlist are in the description below. Let's see what we're doing. Alright, so this is calculator. For 0 to 4, a particle moves along the x-axis with velocity given by v of t equals 3 minus 5 cosine of t cubed over 8 and has position x equals 5 when t equals 3. Okay, so at t equals 3, is the particle's speed increasing or decreasing? To do that, I need to know velocity and I need to know acceleration, because I need to know if they have the same sign or opposite sign. I put it into my calculator, I stored v of t, I found v of 3, and I got 7.864, which is positive. I found the derivative of v of t, which is a of t, at 3, and I got negative 3.903, which is negative. So the speed is going to be decreasing. We just have to figure out how to write that down. So I got v is approximately, so 3 decimal places all times. I think that you should connect a to v, so a of 3 is v prime of 3, that's how you get that point on the free response, is negative 3.903, and then we'll just say since they have opposite signs, speed is decreasing at 3. All right, next up, find the times t with 0, t, 4, c is between 0 and 4, when the particle turns around. So we don't really care which way it turns, we just care that it turns. I'm going to handle this by graphing velocity. So I have graph velocity, and I can see that velocity changes from positive to negative or negative to positive at 1.950, at 3.499, and at 3.864. So this is a calculator question, so there's really not a lot of work that you need to do. So I'm just going to write down those and say because v of t changes sign at these times. You have to give a reason, but the reason doesn't need to be in depth. Like you don't have to specify like moving left to moving right or whatever. You just need a sign change in velocity. All right, next up. Find the position of the particle at t equals 1. So for me, this is a rearranging the fundamental theorem problem. This is my favorite way to use the fundamental theorem. So our position at 1 is going to be the position at 3 minus the displacement that you had from 1 to 3. Right? Because to get to 3, if it was what's the position at 3, it would have been the position at 1 plus the displacement. So to get from 3 back to 1, we have to do where we are minus the displacement. It's a calculator question, so we're not going to do this by hand. X of 3 is 5, that's given, so we did 5 minus the integral, and I get 1.645. So 3 decimals, there you go. D, find the total distance the particle travels while the particle is traveling left. Okay, so total distance traveled is going to be the integral of the absolute value of velocity, but we need to do it on the intervals when you're traveling to the left, which means when velocity is negative. So let's find that. So we need to know, here's our velocity graph. You're moving to the left from 0 to 1.950, and then again from 3.499 to 3.864. You're doing that because velocity is negative. So we need to find the distance traveled on those intervals. So I set this up. And again, it's like all calculator. I forget exactly what the issue is, but the calculator really struggled when I tried to do something on this problem, I think. I don't exactly remember what it was. Maybe it wasn't this problem. I don't know. If your calculator is struggling, I'm going to show you the screenshot of what I ended up doing. I stored x1, x2, and x3 in order. So I'm just showing you that on the first line. I stored those on the graph page, and then I did 0 to x1, I did x2 to x3, and then I just added the absolute value of those together to get approximately 3.802. All right, so that's like a really representative question. You can definitely expect to have to answer those questions on an AP exam. Next up, let y equal f of x be the particular solution to the differential equation dy dx equals y squared over the quantity x minus 6 with f of 5 equals 4. Find f of x. That just means solve. So we're solving the differential. It's like the only thing you're really ever asked to do involving a solution is like solve it. So let's separate and integrate. So again, I'm going to do dy over y squared, but I'm going to make it y to the negative second dy because it's just easier. And then we'll have 1 over x minus 6 dx. Throw some integral signs. I'm going to do plus 1 times the reciprocal on the left-hand side. That gives me negative y to the negative first, but I will write negative 1 over y. And then we have our natural log of the absolute value of x minus 6 plus c on this side. I'm going to solve for c now because y is not inside the natural log, right? If y was inside the natural log, I would exponentiate first. But in this case, that natural log is just going to be in our answer, and we're going to get like a weird answer, I think. So this is what we got. So plug in 4 for y and plug in 5. Better have absolute values there, right? Otherwise, you're trying to do the natural log of -1, which does not exist over the reals. So natural log of 1 is 0. So c is just -1/4. So we can fill that in. We have -1 over y is natural log of the absolute value of x minus 6 minus 1/4. I'm going to take reciprocal, and then I'm going to multiply by a negative to get that y is equal to -1 over natural log absolute value of x minus 6 minus 1/4. I should probably have worried about the domain of this thing. I guess like x technically, the vertical asymptote at 6, so I guess technically the domain is x is less than 6. I'm not going to worry about it on this problem. I don't think you would necessarily be asked for the domain for this, but the solution must be continuous on an open interval that contains the initial condition. So is there a vertical asymptote at 6? I'm not really sure. I don't want to think about the domain of this thing. I didn't think about it ahead of time. I'm not going to think about it now. Okay, so that's the entire problem set. I hope this was helpful, and good luck.